and welcome to this lesson on trigonometry. We're going to be looking at 2D and 3D problems in today's lesson. So what exactly are we doing? Well, let's have a look. We're going to revise some of the area, cos, and sine rules that you have done so far. So area, sine, and cosine rules. We're also going to revise 2D trigonometry application, and we will be looking at some 3D trigonometry application as well. All right, so there's quite a few things that you have learned up until this point, and so it's important for us to revise the terminology, and I'd like you to understand when you need to use each of the formulae. So when do you need to use the area rule, the cos rule, okay, or the sine rule? When do you need to use each of those? So we're going to start today's lesson by giving you a chance just to think about those things and to jot down your ideas. So we'll start by, and if you have a look at this, I would like you to use the triangle below to firstly write down the formula for the area rule and then state when you will generally use it. Also write down the formula for the sine rule, state when you will use it, and then write the formula for the cosine rule, state when you will use it, and you use the triangle ABC to assist you with that. We will give you 2 minutes to have a look at this. Right, everyone, so now that you've had time to jot down your thoughts and when you will use each of these formulae, let's go through this together. Remember, your area, sine, and cos rules help you to solve 2D and 3D trigonometry problems. All right, so let's go through the terminology. I gave you a triangle ABC, and you'll remember the way that we label the sides of the triangle is the side opposite angle A is called A, little a. The side opposite angle B is called little b. And then the side opposite C is called little c. So that's how you name the sides according to the angles that they are opposite, all right? Now, using this triangle, and let's start with the area rule, right? We'll go into where we use the area rule just now. Depending on which angle you are at, so whether you're on A, B, or C, and depending what information you are given, your formulae could be any of these, okay? So, for example, if I want to find the area of triangle ABC, and the angle that I'm given is angle A, and I've got sides BC. So I'm given angle A, and I'm given side B and side C. Then from the area rule, the formula says the area of triangle ABC will be a half the product of the two sides and the included angle, which was sine of angle A. All right? Now say you were given angle B, and then you were given your two sides, which is the side BC, which is little a, and then you were given the side AB, which is little c. Then obviously your area formula will change accordingly. So therefore, the area now when we move to the sine of angle B is going to be a half of A times C, and then sine of angle B, and then the same thing if you move to angle C. All right, so depending on which angle you've been given, your formula will change. All right, the sine rule, so the formula we use, you've seen this before, you've got an angle and you've got a side, so you can say sine of angle A, so sine of your angle A over the side opposite A is equal to sine of angle B over the side opposite angle B, which is equal to sine of angle C, and then the sine, and then the side opposite angle C, which is little c. So what this is telling me is depending on what information I've been given, so whether I've been given angle A and then side A, and then maybe I need to calculate angle B and I've got side B, these are the different pairs of options that you can use depending on what information you've been given. Now what you'll see is in the second formula we've simply flipped that around, so you've got your sides on the top, your A, B, C on the top, and then the sine of the angle at the bottom. And generally when you will use either one depends on what you're trying to work out. So generally if I was trying to work out an angle, I would have sine A over A is equal to sine B over B is equal to sine C over C. So I'd use that version. If I was trying to work out the side, then I would say A over sine A is equal to B over sine B, and so on and so on and so on. So it really just depends on what you're trying to work out. But if you don't want to remember that and you just want to use sine A over A is equal to sine B over B, that's perfectly fine. It really doesn't matter. It may just add 1 or 2 steps more. So it just gives you a little bit more work to do, but they will give you the same answers, all right? And then if we look at the cos rule, and when we will be using the cos rule, we'll talk about that just now. But the cos rule, we've got that A squared, so side A squared, okay, if I'm looking for side A, will be equal to the sum of the square of the other two sides that are given, minus 2 times the product of the two given sides, and then cos of the angle that's opposite the side that you were looking for. So say I was looking for side A, and I'm using the cos rule. That means I'll have to be given side B and side C, and I will need the included angle between those two, right, which is angle A. All right, so therefore A squared will be equal to B squared plus C squared minus the product of the two, and then cos of the included angle. The included angle always being the one opposite the side you are looking for. All right, remember, you can use this depending on which side of the triangle you're looking for. You can change the formula, but the format stays the same. The side that you're looking for is always equal to the sum of the square of the other two sides minus the 2 times the product, and then cos of the included angle. All right, what you also need to be aware of is instead of using A, little b, little c, you can also certainly say AC and AB and BC. Okay, so this can be rewritten as BC squared is equal to AC squared plus AB squared minus 2 AC times AB cos of A. It's the same thing. These are equivalent. Remember, the little letters make it a shorter format for us to use. Now, when will we use each of these? You've come across this. We are revising. You've seen it before, but a lot of students get confused about, well, when do I use the area rule? So this is generally when you will use it. Obviously, it will depend on the question and what information you've been given, but I want to give you a general idea of when you will use each of the formulae. All right? So let's look at the area rule first. So we have the formula already. We've seen what it is. You will generally use the area rule to find the area when there's no perpendicular height given. So if you're looking for the area and you've got no perpendicular height, you will use the area rule. All right. It can also be used in other circumstances, but this is in general, that's when you will use it to find the area. Now the sine rule, when do you use the sine rule? Well, we'll use it when there's no right angle given. Remember, when you have a right angle triangle, you can use your trig ratios. You know, your sine of your angle is equal to opposite over hypotenuse, and then cos is adjacent over hypotenuse. You can use that if you're given a right angle. So when there's no right angle, you can use the sine rule. Also, you use the sine rule when two sides and an angle are given. But importantly, guys, it cannot be the included angle. So for example, if I go back to my triangle and I want to use the sine rule in this triangle, right? Okay, let's say we're using this one. A over sine A is equal to B over sine B. What you will notice is that it cannot be the included angle. So if I was given angle C, right, and I had to work out, say, side A, it wasn't going to work. Unless I've got, you know, two angles so I can work out the third angle, all right? So generally, your sine rule will work if you've got two angles or two sides, but not the included angle, all right? So let's state that correctly. You will use it when you're given two sides and an angle, but not the included angle. Or if you are given two angles and a side. All right? The cos rule, we're going to use that when, again, no right angle is given, because then we can't use our trig ratios. We'll also use it when two sides and the included angle are given, or when three sides are given. All right, so that's just general hints and summarizing what you already know about those formulae. And by now, most of you are very familiar with when you should use each one. So before we go into break, I would like you to take down a question for me. And there is a drawing. So what I would like you to do is take down the drawing, and on this drawing, put down all the important information. When we come back from the break, we'll go through this together, but I also just want to give you 2 minutes before the break to take this question down, and on your diagram, jot down all the important information. 2 minutes. Okay, everyone, so it is time for us to take a break, but during this break, use the time to study the information that you've been given and attempt to answer the question. We'll be back after this and we'll go through this together. Welcome back, everyone. So reminder that we are looking at 2D and 3D problems, and we started out by reminding you about all the different rules that you've learned, the area, the cos, and the sine rules, and then we had our first question for you to look at. Now let's go through this question together, and what I'd also like you to do, if you have the Casio calculator that we use, which I'll talk about just now, and you like to learn a few calculator tricks, it's not really a trick, it's really just showing you how to use your calculator more efficiently. I'm going to go through that those calculator steps in this question. So if you've got your calculator, your Casio calculator, FX, any range, then keep that on hand and we'll go through the steps together. All right, on the calculator. So I want to show you in this question. So if you don't have your calculator, go and get it now. You're going to need it. All right, so let's go through the question together. Once you've got a trig 2D question in this case, you need to read and understand what's going on, okay? So you've got two vertical towers, A, B, and C, D, and you can see that that's drawn on your diagram, A, B, and C, D, obviously being vertical. Your towers are going to be at 90 degrees to the ground. If they weren't at 90 degrees, they're going to be a lopsided tower, so they're going to slant to one edge. So your towers will always be at 90 degrees to the ground, perpendicular. They tell you the heights are 30 meters and 27 meters high, respectively. Respectively, remember, that means in that order. So we had AB first, so that means AB is going to be 30, and then we follow that with CD, so CD is going to be 27. Point P lies between the two hours, okay, and between the two towers, sorry, so you can see that that's drawn for you. The angle of elevation from P to A is 50 degrees. The angle of elevation, so if you think of this almost as your eye and then you're looking up, all right? So elevation, looking up. So that angle is 50 degrees. And from P, so we're looking up again from P to the top of the tower, point C, and that angle is 35 degrees. And they tell you that a cable is needed to connect A to C. So that's your cable there, it's connecting A to C. The question is, determine the length of this cable AC to the nearest meter. Okay, so look at your diagram and look at what you've been given. And ask yourself, well, if I want to get to AC, what do I need? Now, generally, when you attempt any 2D or 3D application, you're going to work in the triangles with the most information and then work towards getting into the triangle and the length or the angle that you need. So when I look at this diagram, I see that the two triangles with the most information are obviously APB and CPD. So those are the two triangles with the most information. So CPD and ABP. All right, so I'm going to start with those triangles and then work into my third triangle being APC in order to work out the length, which is AC. Now, if I need to work out a length, obviously I'm going to need an angle in triangle APC, and we can quite easily then work out that this angle APC using angles on a straight line will be 180 degrees minus 50 plus 35. And your reason there is obviously angles on a straight line. So 180, you can call up your calculator, 180 minus 50 plus 35. And you see here my calculator, FX82ZA, that's the one we're using. So the calculator steps I'm showing you will all be based on this calculator. So you'll need to learn if they're different. Obviously, your simple math is always the same, but you will need to, if you've got a different calculator for later on when I'm showing you different steps, then you'll need to learn how to use the calculator that you have. All right, so for the FX82ZA, we've got that my angle is 95 degrees from there. All right, so I've already got an angle in that triangle. Having an angle is not enough. I need to have sides as well if I want to work out AC, All right, so this is the one I'm looking for. We work in the two triangles with the most information, okay? So in triangle ABP, I can work out what the length of AP is, right? And in triangle CPD, I can work out what the length of CP is. Once I have AP and CP, I can then use the cos rule to work out the length of AC. All right, so let's put down the steps for that. Okay, so you can take them down or you can work it out. So we're going to say in triangle ABP. Now look at your triangle. It's a 90-degree triangle, right? It's a right triangle. So therefore, I don't need to use the sine rule. So some of you might say, well, I can use the sine rule. Yeah, you can, but it's going to be more work. So we work in triangle APB, but we're going to use our trig ratios. So I'm going to say, well, looking at this angle here, which is 50 degrees, right? What am I looking for? I'm looking for AP, which is the side opposite the 90. So that's my hypotenuse. What have I been given? I've been given the opposite side. So the unknown, or if you want to do it the other way, the known over the unknown is going to give me 30, which is opposite, over hypotenuse, which is sine of 50 degrees. So therefore, in triangle APB, sine of 50 degrees is equal to 30, which is opposite, over my hypotenuse, which is AP. You can then cross multiply so that we get AP on its own. So we get AP is equal to 30 divided by sine 50. Okay, and then we're going to do that on our calculator. I'm not going to do it right now because I want to keep the calculator steps to the last. All right, let's look in the other triangle. So in triangle CDP, we have that. Okay, so let's go back to our triangle. So I'm looking at this little triangle on the side. I'm looking at this angle 35 degrees. What have I been given? I've been given the opposite side, and I'm looking for the hypotenuse. So once again, we're dealing with the trig ratio, sine. Sine is opposite over hypotenuse. So I can say, well, sine of 35 degrees is equal to 27, which was the opposite side, over the hypotenuse. So therefore, if I cross multiply, I'm going to get that CP is equal to 27. So I cross multiply, divide by sine 35. So CP is 27 over sine 35. All right. Now you'll notice that I haven't put answers down for these, and this is where I want to show you how you can use your calculator efficiently. Now remember, and this especially comes in when we do 3D problems, but we need to get into this habit already. Often your calculations will say to the nearest meter or to, round off to 2 decimal places. If you round off in intermediate steps, what's going to happen is it's going to affect your final answer. And it might be slightly off, okay, by a meter or 2 and so on. And we want to be as accurate as possible. So the one way to do it is to work out your answer and then write down the answer with all the decimal places in. Or we can simply use our calculator to store the answer in the memory and then call up the answer later on. So let me show you how to do that. Okay, so we're going to do both of them together. So in the first one, okay, so I've got my calculator. Remember, the one I'm using is the FX82ZA, but if you've got another calculator, please learn how to do the steps on your calculator. All right, so for the first one, we were looking at 30 divided by sine 50 to find the length of AP. So I go 30 divided by sine 50. All right. And I see I get 39,16 and then other decimal numbers, right? The one thing you can do, the one way to do this is to write down all these numbers. The other way is to store it in the calculator memory. Now, how do you store in the calculator memory? On your calculator, you use Shift, then you press Recall, which gives you the base of the calculator, which hopefully you can see on your screen says STO, another word for store, right? So you go Shift, Recall, which gives you the Store button. Which memory do you want to put it in? You see in your calculator you've got variables in red. It goes A, B, C, D, E, F, and then there's X, Y, and M. Those variables, you can use that almost as a memory storage. So I'm going to store this in memory M. And you see a little M comes up on the left corner telling you that this answer has been stored. So let me show you how we would recall that. You'll say recall M, and that gives you your entire answer. So as I said, if you want to, you can certainly write down all those decimal places. I think it's a bit time consuming to always be writing down all these decimal places, but if you want to, you can do it that way. If you prefer not to learn the calculator steps, okay, you can write down all the decimals. All right, let's do the next one. So the next one we have to say 27 divided by sine 35. And the reason I'm storing this, guys, is because I'm going to need these numbers for a later calculation. So that's obviously why I'm storing it in the memory. So I go 27 divided by sine 35, and this gives me the length of CP. And I get that answer, 47,07. So once again, yes, you can write it all down. Or you can now store it in a different memory. So the last time I used memory M. This time I'm going to use memory A. So do you remember how I said we stored? We say Shift, Recall, which takes me to the Store button. What memory do you want to put it in, or what variable do you want to assign? I want to assign A. So then that answer is going to stay in memory A. All right. Okay, if I want to recall it, I'm going to say recall A. And there you go, your answer's there. Okay, so it's a much more efficient way to store your answers for later calculations. And that's why I'm taking so much of time and making it such a long process, because I want you to be able to use your calculator efficiently. Okay, so now that we've got those two lengths, how are we going to work out the side we want? So we look at our triangle. All right, so look at your drawing. We've got triangle APC, and we're trying to work out length AC. So there, what have I got? I've got these two sides, PC, and I've got AP. So I can use, what do I have? I've got two sides and an included angle. For me, the first thing that jumps out as me is cos rule. Two sides and an included angle, we're going to use the cos rule. So we'll say AC squared is equal to AP squared, which is the side that we worked out, plus PC squared minus 2 times the product of those, and then cos of the included angle, which was cos of angle APC. All right, let's put some numbers in. So AP squared, for now I'm just going to use the abbreviated the rounded off forms, but in my calculator workings, I won't do that. I'll put the whole thing in. So it's going to be 39,16 squared plus PC squared, which is 47,07 squared, minus 2, and I'm going to continue underneath. 39,16 times 47,07. Again, those continue, and then cos of your included angle, and the angle there was 95. All right. So we're going to use our calculator, and hopefully it works out nice and efficiently the way I want to show you it would work out. We're going to use our calculator to put this entire expression into the calculator, but we're going to use the memory buttons in order to do this. Okay, so call up your calculator. Hopefully you were following me with those steps, okay? And let's just call up our memories that we need in order to do this calculation. Okay, so it's going to be AP squared. So I'm going to say, recall memory that one, and it's going to be that squared plus the next one. Okay, in fact, I just want to show this to you a little bit differently so you see the memory numbers coming up. Another way to recall your memory is if you hit the alpha button, it brings up the M, which is your memory M. So let's do it that way. So it's going to be M squared plus I go alpha A, that's going to be squared, minus 2 times M times A. So it's storing all the numbers that are in M and A. And then it's going to be times cos of 95. All right, so that's what we get. We get 4,070, 8933.92. All right, so that's what we get for AC squared. But remember, we are not looking for AC squared. And you saw how nicely and neatly the calculator did it all for us without us having to worry about writing down those long numbers. Okay, we need to learn how to use our calculator effectively. Okay, so I need to take the square root of this 4,070 in order to get AC. So I say square root of that answer. And my answer is 63,8. But they said to the nearest meter. So 63,8. The nearest meter to 63,8, we round up, so it would be 64 meters. All right, so it took us some time to do that, and it took a lot of effort as well, and I hope the main thing I want you guys to remember is how to use your calculator to store those numbers in, because as you get into more tricky questions, it becomes a lot more work to have to write down those answers. All right, so let me write down that step for you quickly to store a number in the memory of your calculator, provided you're using, of course, the same calculator that I'm using. If you've got a different calculator, go through the manual and see what the steps are for storage and memory. All right, so this is what we do. So on your calculator to store, okay, you say, hit the shift button, then you press the recall button, which actually gets you to the floor of the calculator, the base of the calculator, which says store. And then you hit whichever memory or variable you want to store in. So either any one of those. All right. To recall it, there's two ways. So if you want to recall your answer, you can either press recall and then the variable, or you can hit the alpha button and then any of whichever memory you used. Okay, I hope that you all found that very, very useful. I think it's a nice tool to have at your disposal. I think it's time for us to take a quick break. We'll come back and do more questions after this. Welcome back, everyone. So a reminder that today we are looking at solving 2D and 3D problems. So far we've looked at two-dimensional problems, but we need to talk more about 3D or three-dimensional problems. Now, you know, while yes, trigonometric formulae can be used to solve 2D problems, in the real world, most of the objects around you, or all the objects around you, are three-dimensional, right? They've got length, width, height, breadth, or other dimensions, okay? So we need to be able, and we need to practice using those formulae to do 3D or three-dimensional problem solving. All right, so that's what we're going to do in this segment. And also what you need to practice and you need to understand is how you have to come up with a diagram in order to work a question out when they've just given you the writing or just the statement. So it's important skills that you need to have, and that's what we're going to focus on now. All right, so I'm going to give you 2 minutes just to take this question down and then attempt the drawing. We will come back and go through the drawing together, but just attempt the drawing, get down all your key information that you need in order to get this drawing correct, because the main part in getting a three-dimensional or any dimensional problem correct is putting that information in the correct places, all right, if you weren't given a diagram already. So let's have a look at this question. We will give you 2 minutes to take it down. Okay, so now that you have the question done, hopefully some of you have made an attempt at the drawing and hopefully some of you have got it correct. But you will agree one of the most challenging parts of answering a question like this is because you've just been given a description, to get all that information down into a diagram is quite a challenge. So you need to understand exactly what they're saying. And the importance here is also understanding your different planes, your horizontal plane and your vertical plane, okay? One of the worst mistakes you can make is think of this as a flat shape. You will get yourself into all sorts of trouble if you do that. So let's have a look at how we do this question. All right, you were told that T is the top of a pole and its base is F. It is in the same horizontal plane as the points A and B. So the first thing we need to do is, as I said, it's a challenge to analyze it, so we need to represent this in a drawing. Okay, so how does my drawing look? Well, I've got the point T being the top. All right, they said it is the top of a pole and its base is F. Now, if it's a pole that's constructed and it's made correctly, it will be perpendicular to the horizontal plane, right? So that angle at F is going to be 90 degrees to show that it's perpendicular. They also tell you that F is in the same horizontal plane as the points A and B. So now we're working in a different plane. So we've got the points A and B, and I'm not sure if you can see it clearly on your screens, but it definitely is in two different shades on my drawing. So I can see that FAB is in a different plane. It's in the horizontal plane, and TFB is your vertical plane. Okay, so hopefully you can see that quite clearly. So we've marked out that A and B and F are in the same horizontal plane. Okay. They also tell you the angle of elevation measured from B to T is 25 degrees. So going from B to the point T, so we're now in the vertical plane. I'm looking up from B to T. That angle is 25 degrees. They tell you that AB is 120 meters, which is also on your drawing. So we've got AB. We marked down, basically put down all the information on the drawing. So AB is 120 meters. That's the distance between the 2 points. Angle FAB is 40 degrees. So angle FAB, that angle there, is 40 degrees. And then also you've got that angle FBA is 30 degrees. And we've got all that information marked in the sketch that we've made. Okay, they say use the information to calculate H, which is the height of the pole to the nearest meter. So what are they looking for? They're looking for H. Okay. Importantly, I just want to remind you here, and that's why I spent so much time on this in the last question, do not round off the answers in the intermediate steps. This will affect the accuracy of the final answer. So you're always going to try to do the calculation in one step and only round off the final answer. And this is why being able to use the memory on your calculator effectively is so important, because you can just store those answers in and then you don't lose any accuracy at all. Okay. All right. So let's talk about this question. Have a look at your drawing. You need to work out height TF, which is the height of this pole, which is H. So what you do is you start, as I said to you before, you start with the triangle with the most information. And we see that that's happening in triangle FAB. So that's the triangle with the most information. And then you see how is this triangle FAB related to the triangle in the other plane, TFB. And we see that there's a common side, right? There's a common side joining those two. And that side is side FB. Okay, so that's your common side that's joining those two together. Okay. And we then say, okay, well, we need to work out, if I want to get into triangle TFB, I need to work out the length of FB, because that's the one that joins the two together. Once I've got the length of FB, you will then agree we've got enough information in triangle TFB. We've got an angle, we've got a 90-degree triangle, and we've got a length. So we've got enough information to work out the length of H using our trig ratios. Okay, so we can use sine rule, yes, but that's going to be much longer. We can use our trig ratios instead because FTB is a 90-degree triangle. It's a right triangle. So let's put the steps down for this. All right. And you can take this down. You can, again, remember, we'll do this in the calculator as well, and you can take those steps down as well. So we start by saying in triangle FAB, right? So in triangle FAB, that's the one in your horizontal plane. I first want to work out, well, I want to get to FB. What information do I have? I've got only one length, AB. And I need to find FB. I've got the angle opposite FB, so that's kind of hinting to me that the rule I want to be using is the sine rule. In order to use the sine rule, I need to work out angle AFB. Okay, and because we use angles in a triangle, we can work that out quite easily. So angle F is equal to 180 minus 40 minus 30, and this is angle sum of triangle. All right, so therefore angle F will be 110 degrees, 180 minus 70. So angle F is 110 degrees. So therefore I've got enough information in the triangle now to work out the length of FB. So we put this down into our sine rule formula. So I can say FB over sine of angle A is equal to AB over sine of angle F. All right, what am I looking for? I'm looking for FB, so we can cross multiply and get that FB will be equal to AB, which we have the length of, which is 120, times sine of angle A, and we know that sine of angle A was 40 degrees, that's it, over sine of angle F, and F we worked out was 110 degrees. So I'm basically just cross multiplying there and getting FB on its by itself. All of this we can put into our calculator. Now guys, you will remember that we still have information in our memory on our calculator. So I want to show you how to get rid of that information. I want to use memory M again. So to get rid of what's in memory M, I go Naught, Shift, Store, M. So in other words, I'm saying put nothing into that memory bank now. So now it's cleared out. Now there's nothing in there and we can use it for this calculation. Okay, so let's do all of this in our calculator. We're going to have 120 times sine of 40 divided by sine 110 degrees. Okay, so that gives you 82,084. You can write it all down, or we can use our calculator. We store this in our calculator memory by saying Shift, Store, M. So now that answer is in memory bank M when I need it later on. Okay. All right. So now that we've got FB, right? Remember, that's the one we said we needed. Now that I've got FB, I can work in triangle FTB, and I can work out my height H. What are we looking for? Well, we look at the angle we've been given, which is 25 degrees. I see that the side opposite 25 degrees is H, so that's the one I'm looking for. What have I just worked out? I've worked out the adjacent side. What is the ratio opposite over adjacent? It is tan. All right, I can use this ratio only because I've got a 90-degree triangle. If it wasn't a 90-degree triangle, we would not be able to use it. All right, so we say in triangle TFB, tan of angle B, which we know is 25, is going to be equal to FT over FB. Okay, so therefore we can say, well, the one we're looking for, which is FT or H, is going to be equal to, cross multiplying again, FB times tan of angle B. We have worked out the length of FB. For now, I'm going to use the approximate value, but we'll use it in the calculator. We'll use the whole value. So we've got 82,084 times tan of 25 degrees. And let's work that out. Okay, and remember FT is the same as H. Okay, so using my calculator, I recall what I had in the memory bank. So you can go alpha M or recall M, it's the same thing. And we say times tan 25. And that's going to give you an answer of 38,276 and so on. So therefore, to the nearest meter, this will be 38 meters. Okay, and you see that it's so much, you retain so much of accuracy in your calculations when you know how to effectively use that memory button. Okay, so please, please, please practice how to use that memory button for storage because you want to get accurate answers with your calculations. All right, so it is time for us to almost say goodbye, but I want to just remind you about the key concepts that we learned in today's lesson. We discussed the area, cos, and sine rules, and you saw when you use each of those formulae. And the important thing that you need to remember when you deal with three-dimension problems, where they just give you a description, is that you need to draw a sketch. You have to draw a sketch, and your sketch needs to reflect that you are dealing with two different planes. So you're dealing with a horizontal plane and a vertical plane. It's so, so important to get that drawing right and not to treat that drawing as if it were a flat shape. If you treat it as a flat shape, you're going to make all sorts of mistakes. And then the very important thing that I showed you in today's lesson, for those of you who like to use your calculator and you like those little, hints and tricks and things you can do with your calculator, I showed you how to use the memory button, which really, really helps you to retain accuracy in all of your calculations. So I hope that you've learned a lot in today's lesson, and I hope that you're going to apply this in the questions that you have for homework as well. All right, until next time, cheers.